Hi, welcome to my YouTube channel, Theoretical Physics with Mark Weitzman. I'd like to do a weekly blog, just update what I'm doing this week. Most of what I'm doing has to do with quantum field theory, but I'd like to start by reviewing courses. So several courses, one starting tomorrow, Computational Data Science and Physics. If you go to the MITx online site, you can sign up. That starts tomorrow. There's another course, Math Boot Camp for Engineers. This is probably not that necessary for physics students, but if your math is weak and you want to review a lot of stuff, you can do it. And you might want to take a look at this course. And that starts at the end of the month. And then finally, a course that many of you ask me about, when is it coming? Now I can say it's coming on August 16th. Mastering Quantum Mechanics, which is basically 8.05x at MIT. And in a way, this was, I think, the best MOOC I've ever taken, certainly in the top 5 MOOCs. I would list, if I had to list like the top 5 MOOCs, I'd list Mastering Quantum Mechanics. I'd list the MIT Probability MOOC, 6.04. I'd list the Learning from Data, Caltech MOOC on machine learning, which ran about 10 years ago. I would list the electronics, the introductory electronics course at MITx. And I would list the Russian course, which unfortunately with the world situation might be a long time before we ever see that again, but the physical applications with complex analysis. Those would be my 5 top MOOCs. And of those 5, I think the Mastering Quantum Mechanics was the top one. Just in terms of resources available and everything else. So there's one other course that I've signed up for. I'm not sure how serious I'll be. For those who are interested in all this new artificial intelligence and chat GPT, there's a large language models course offered by Databricks. You can find it, and it just started about a week ago. And if you're into that, that might be an interesting course for you to take. As I've said, I spent most of the past week sort of reviewing things on spinners, Dirac spinners, 4-component Dirac spinners, marijuana spinners, wild spinners, all this stuff. And I even read some of my old chapters in old books. Oops, I'm a little sorry. Like here's my old telephone book on gravitation, but even it has a chapter 40 on spinners and everything. And these are like 2 pages from it. You can see it's near the end of the book. I never paid much attention to this because I didn't know much quantum mechanics when I first studied general relativity. I studied this book when I was a senior in high school. I started reading Meisner, Thorne, and Wheeler. And by the way, the book has a reputation of being difficult and hard for general relativity, and I don't think that's true at all. I think it's an excellent book. The only problem is it's a little wordy. It's 1,200 pages. It should be about 600 pages. But other than that, it's an excellent book. And but I always remember this diagram. I didn't know at the time all those things about the Dirac-Bell trip and the Feynman plate trip. This is their version of it, about how 2 rotations return you back to where you were, whereas 1 complete rotation still leaves you tangled. Anyway, another old book that I started reading to review. This is a great book. I'm going to show you a copy. It's hard to get on. It's so old, but it's called Supersymmetry, an introduction with conceptual and calculational details. And the great thing about this book, I think you can get it on Amazon, but the great thing about this book is that every page is like handwritten with equations like this. They don't leave out any details. So this is if you were solving the equation or the problem yourself. And if you want to just go through the first 150 pages of this book, are a detailed description of the Lorentz group, of spinners, and everything. And if you just wanted, this is, I'm taking this, oh, I'm sorry, it's not showing. So this book is a available on the, you could go to the Internet Archive and borrow it for a little while, but every 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 page of the book is just handwritten equations like this. They work out every detail. Almost nothing is left out. The first 150 pages just, over and over again. Just, it's great to read. You don't need pencil and paper because everything is done for you. In a sense, that may be a negative thing, but it does the whole thing with the homomorphisms of the complex and the transpose inverse and everything. And this is one of the best books to learn about the Lorentz group, Poincare group. And if you're confused about Weil spinors, Dirac spinors, marijuana spinors, this just does that in complete detail. So it's not an easy book to get a hold of. I think it's available on Amazon, but regardless, you can go to the Internet Archive and just read through it. You can borrow it for like an hour at a time. This is a great site, the Internet Archive. You don't pay anything. You just log in and borrow books for an hour at a time and read. But it just goes on and on. The first chapter just goes forever. It's like 150 pages. And as you can see, everything is just, there's very little words. There's some words, and it's good, but so that's that. And as I said, this is my quantum field theory resources page on my Piazza site. I've got I'm trying to keep everything, update all my textbook notes and everything. Someone asked me about these notes from this individual, his name was Schranz Notes. It's like 2,000 pages on quantum field theory, Stanley M. Schranz, and this literally goes for like 1,800 pages. It's basically mostly Peskin and Schroeder, but it has like a chapter from Weinberger here and there, and it has a chapter from Schwartz here and there, and it's a little bit more detailed than Peskin and Schroeder. But mostly, it's like he said, he shamelessly follows it. And he's got some things, especially at the end, which go a little beyond that. But it's like 1,800 pages of latex notes. So now this is his summary. Once he gets to like page, let me start. I think when he gets to page like 150, now he's just going to be following a lot of Peskin and Schroeder word for word almost. Not word for word. He gives his own take on it. It's very interesting notes. My own notes, I'm trying to this is my notes on Swignecki. And I'm actually, I only got like 3 chapters of the start of the book. I need to get going on this. And you can see I have 3 chapters, but I'm also filling in next couple of days. I'm going to fill in a lot of part 2 on the representations of the Lorentz group and everything. And the same thing with my notes on Z's book, which I've just started. I've only got up through part 1, chapter 7 essentially, and I need to fill in these things. These Feynman diagrams, I'm not that good at them. It's hard to get them, exactly right and everything. But I'll get there. And at the end of the book, the appendices is what I'm working on right now. I've started with a brief review of group theory. He has a pretty good review of group theory that you need for quantum field theory. And then he's got an excellent appendix on dotted and undotted indices in the marijuana spinner. So I hope to fill that out. And as I said, I've got my goal is to start maybe doing some live broadcasts in the fall, but I've got version 2 means that, I've looked at it, and it doesn't mean all the stuff is new, but at least that's as much as I'm going to do on version 2. In version 2, I'm up through, I've got about 5 lessons, 3.5 is a lesson, and then I've just completed lesson 4, version 2. So I uploaded a lesson yesterday on a problem 4.1 in, I don't know why it's not here. Should be here. Okay. Let me put it like this. No, those are the notes. These are handwritten notes. Well, I have to put a link to the new video that I uploaded on YouTube yesterday. And then these without a version 2. Here's another version 2 lesson I need to complete. But I need to make these all version 2s. And part 1 will have like 40 lessons, 38 lessons, because that's how many chapters are in Czerniecki's book for part 1 on scalar fields, and then spinor fields and so on. So that's mostly what I'm working on right now. So thank you for watching, and I'll try and continue this weekly blog. Bye-bye.